Alright, on this video we're just going to be doing some derivative practice, and I mean really the only way to get good at them is to just do them over and over and over and over and over until you just kind of get it beat into your head as far as how to take these things. Alright, so just get started. Say we have, let's just say 3, and we want to know what dx of 3. So what would that be? Another way to write the derivative is just say 3 prime, and that is going to be equal to 0. Alright, and that's because we have a little rule saying that just say d dx of a constant is going to be equal to 0. And that's just one of the rules, because if you go through and actually do the limit definition, the limit as h goes to 0 of f of x plus h minus or f of x all over h. Whenever you go through, well, we take and plug in our x plus h wherever we see in x. Well, we don't have one of those, so we just say 3, and then minus our f of x, which in this case, is 3, and that's all over h as the limit as h goes to 0. Well, so that's going to leave us with 0 over h, which is just 0. So that's why the derivative of a constant is 0, because we just have the constant minus the constant from top. So we'll just go to another slide. So that being said, what is the 9 prime? It's going to be 0. 10 prime is 0. Say 2 to the 10,000. It's going to be 0. I mean, it doesn't matter what you do. The derivative of a constant is always 0. So the sooner you get that actually ingrained in your head, which I'm sure most of you do, going to be better off. Alright, so now going through another rule that we have, say d dx, which is the same thing as saying taking the derivative with respect to x of 2 times x. Alright, well, that's in the form of a constant times the f of x so d dx. Whenever you have one in that form, it's the same thing as saying the constant, which you just pull out to the front, times the derivative of that function, of the f of x. Alright, so now you can just say excuse me, that if you want to take the derivative of 2x, you just pull the constant out front, and then you take the derivative of your f of x, which is just x, and in this regard it is just 1, so it's going to be equal to 2. Alright, so just going through and doing the limit definition. The limit of h goes to 0 of our 2x. So we just say 2. And this is going to be our f of x plus h. Just say x plus h minus our f of x all over h. It's going to be equal to the limit as h goes to 0 of 2x plus 2h minus our f of x, which is 2x, all over h. Well, you can see that that one and that one right there, the plus 2x and minus 2x are going to cancel. And so that would just leave us with 2h over h. And the h's will cancel, which is just going to leave us with 2. So that's how that goes. So you can practice those as far as just going through using some of the properties of the derivatives and everything else. And I mean, just play with it and have fun with it if you can have fun with it. But just play with it, go through, try to use the actual rule for it, the properties of a derivative. And then once you take it and you find out what your derivative actually is, just go back and plug it into the limit definition of a derivative. And just practice doing those, because the more practice you get, the better you'll get at it.